Hello, Welcome to our life. Are you sad? Are you hurt? Are you lost? Are you lonely? Worry no more. You are at the right channel. Welcome to Excuses!
Good day, mga ka-X. Here's your first lesson for Grade 10 exclusive discussion. For this video, we will discuss on Lesson 1, generating patterns and illustrating arithmetic sequence. Let's begin.
Patterns are everywhere. And that is simply true. These patterns are easily found in nature or in man-made structures. These are just few examples of patterns that you could actually see everywhere.
Talking about patterns, the knowledge of listing and ordering sets are prerequisite skills used in recognizing and generating patterns. In mathematics, a sequence is a set of numbers that follows a definite order or rule. This sequence of numbers is represented by a sub 1, a sub 2, a sub 3, up to a sub n. The list of numbers in a sequence are called terms, denoted by a sub 1 for the first term, a sub 2 for the second term, a sub 3 for the third term. The expression a sub n refers to the n term of the sequence. Moreover, the domain of a sequence is either finite set or infinite set. For example, finite sequence. 1, 2, 3 has only 3 terms, while infinite sequence 1, 2, 3 has an endless number of terms, denoted by the 3 dots, called ellipses. In mathematics, we use the expression a sub n, which refers to the n term of the sequence. And the subscript n refers to the term number, used to identify the location or position of the term within the sequence. Hence, if we are given an expression a sub 5, we are looking for, yes, you're right, that is the 5th term of the sequence. Example number 1.1. Here is a table of a certain sequence. Let n be the number term, and a sub n indicates the specific location or position of the term of the sequence. Now here, we are expecting 10 terms, but the last 3 terms are unknown. Now let me read this to you. What pattern can you observe in the sequence above? Given that a sub 1 is 7, a sub 2 is 14, a sub 3 is 21, and a sub 4 is 28. And what is the nth term of the sequence? That means we are going to get the rule. Going back to the table, our objective for this part is to get the rule or pattern that is being observed in this sequence. So let's check. For our first term, again, that is 7, followed by 14. Now the question is, how did we get 14 from 7? That is, we added 7. So 7 plus 7 is 14. Let's check the other terms. 14 plus 7 is 21. 21 plus 7, 28. 28 plus 7 is 35. 35 plus 7, that's 42. And 42 plus 7 is also 49. So, with this method, we can manually solve for the 8th, 9th, and the 10th term. But what if you're asked for the 100th term of the sequence? Well, that will take you a very long time. So, in this case, we really have to write the formula for the rule of this sequence. So how are we going to do that? Going back to the first term of our sequence, that is 7. So if we're going to check, for number 1, there is 1 7. For number 2, there are 2 sevens. For number 3, there are 3 sevens. So let's check that. Again, for number 1, for our first term, we have only 1 7. For our second term, that is 2 sevens. That is why we got 14. For number 3, we have 3 sevens, giving us 21. So with this pattern, I think we are ready to write the rule. So therefore, our n term would be a sub n equals 7n. If you notice, here n is the same with the position. So we simply substitute n with the position of the sequence. And therefore, the n term of this sequence is represented by a sub n equals 7n. Now that we already know the rule or pattern for this sequence, it will be easier for us to determine for the 8th term, the 9th term, and the 10th term. So again, the formula was a sub n equals 7n. Always write the rule first before solving for the term. So in this case, we have the 8th term. That would be a sub 8 is equal to 7 times 8. And that will give us 56. That is the 8th term of our sequence. Let's fill in the table. Moving on to our 9th term. So that is a sub n equals 7 times 9. That will give us 63. And that is our 9th term. Let's fill in the table for our 9th term. And lastly, for a 10th term, that would be a sub 10 equals 7 times 10. That will give you 70 for our 10th term. And we have finally completed our table. So, therefore, our 8th term is 56, our 9th term is 63, and our 10th term is 70. I hope you get that. For the next example, we will jump to 1.3. For 1.2, you are expected to study it on your own. No need to worry. Details of solutions are given on your module. Now let's proceed. Here, we have a table with 7 terms, but the last 2 terms are missing. Now let's read. What pattern can you observe in the sequence above? Given that your first term is 7 halves, followed by 4. Your third term is 9 over 2. Your fourth term is 5, and so on. And don't forget, you are also tasked to solve for the n term of the sequence. Now we are on our favorite part, finding the rule of the sequence. So going back, 7 halves or 7/2 is our first term, followed by 4 is our second term. So what did we add to 7 halves to get 4? That would be 7 halves plus 1 half. Because that results to 8/2 or 4. So that is 4 plus 1 half, or 8/2 plus 1 half is 9/2. 9/2 plus 1 half, that is 10/2 or 5. 10/2 plus 1 half, that is 11 halves. So try to think, what number is added with 1 half to get 7 halves? Now let's write it down. Okay, that would be a sub 1 is equal to blank plus 1 half. That is 7 halves. So that must be 6 halves or 3. So that is 3 plus 1 half equals 7 halves. So our second term would be 3 plus this time there are 2 1 halves. So 3 plus 2 times 1 is 2 divided by 2 is 1. And that's why you got 4, which is right. Now I think we can write for the rule. That is a sub n is equal to, our constant number is 3 plus 1 half n. Okay, that's it. Therefore, the n term of the sequence is represented by a sub n is equal to 3 plus 1 half n. Using the rule, I am pretty sure you're confident enough to solve with me the 6th and the 7th term of the sequence. Going back, the rule that we got was a sub n is equal to 3 plus 1 half n. To solve for the 6th term, again, we will substitute n with 6. Now let's start solving. We have to write first the constant number 3. So that is 3 plus 1 half n. Here n is 6. So 3 plus 1 times 6 is 6/2. Copy 3. 6 divided by 2 is 3. So 3 plus 3 is 6. And that's our 6th term. So here, our 6th term is 6. What about for our 7th term? A sub 7 is equal to 3 plus 1 half times 7 equals 3 plus 1 times 7 is 7/2. In this case, we cannot divide 7 by 2. So it's impossible to directly add whole number in a fraction. So let's get first the LCD, which is 2. 2 divided by 1 is 2 times 3 is 6. Now simply copy 7. So 6 plus 7 is 13/2. And that is our 7th term. Okay, so I think we're done. Therefore, our 6th term is 6 and our 7th term is 13/2. We are now on our third example. We jumped on example 1.5. Here, this is pretty much similar to 1.4, but the previous one is much easier, so we believe that you can study it on your own. Now let's do the 5th example. Write the first 5 terms of the sequence given by a sub n equals 3n minus 1 half. Now let's continue and proceed with solving. So here, 5 terms will be solved, and what was our n term? That was a sub n equals 3n minus 1 half. Let's start solving for our first term. So that would be a sub 1 is equal to 3 times 1 minus 1 half. 3 times 1 is 3, then copy minus 1 half. You cannot directly subtract a whole number and a fraction, so you have to get first the LCD. In this case, that is 2. So 2 divided by imaginary 1 is 2 times 3 results to 6. Then you can copy directly minus 1. So here, 6 minus 1 is 5. Copy the denominator 2. So our first term here is 5 halves. Moving on to our second term. That is, a sub 2 equals 3 times 2 minus 1 half. 3 times 2 is 6 minus 1 half. Then get the LCD, which is 2. 2 divided by 1 is 2 times 6 got 12 minus 1. That results to 13 over 2. And that is your second term. Let me write it again. 13 over 2. Moving on to our third term. That is a sub 3 equals 3 times 3 minus 1 half. 3 times 3 results to 9. Copy minus 1 half. Getting the LCD, that is 2. 2 divided by 1 is 2 times 9, that's 18. Then copy minus 1. So 18 minus 1 is 17. Copy denominator 2. So that is our third term. Now let's proceed to the fourth and the fifth term of the sequence. Let's have first the fourth term. So in solving for the fourth term, that is a sub 4 is equal to 3 times 4 minus 1 half. 3 times 4 is 12. Copy minus 1 half. Then you get the LCD, which is 2. 2 divided by 1 is 2 times 12, that's 24. Then you can copy minus 1. So what is 24 minus 1? That is 23 over 2. And this is in its simplest form, since 23 and 2 doesn't have a common factor. Now let's have the last term. A sub 5 is equal to 3 times 5 minus 1 half. 3 times 5 is 15. Copy minus 1 half. Then you get the LCD, which is 2. 2 divided by 1 is 2 times 15, that's 30. Then you copy minus 1. What is 30 minus 1? That is 29 over 2. And still, they don't have a common factor, so this is in its simplest form. So, let's review. What are the first 5 terms of this sequence? Here we go. We have 5 over 2, 11 over 2, 17 over 2, 23 over 2, and 29 over 2. So that's it. We're done with our discussion. Thank you for keeping up with our lesson.
If you find the lesson confusing, feel free to hit the replay button. Replay! 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 Replay!